So the square root is already printed on the page, and the sign has already been decided for you. The sign has already been decided. So you don't do plus and minus. Okay? I'll be right back to the screen if you're still writing. I'll be right back, so don't freak out. Let me go back to the startup. I can go back. Okay, with the startup, the square root on number 1 was already given, right? It was originally printed. So, what's the sign? Was it positive or negative in front of the radical? Seth?
Question.
Okay.
How would negative 3 times negative 3 times negative 3 equal 9?
That's for a cube root.
Oh, wait, never mind. Now I get it. Oh.
Okay.
Go ahead. Go ahead.
All right, so back to this. The square root is already written, so the sign is given. What's the sign in front of this radical? Is this a positive radical or a negative radical? Positive. So if you look at our answer, that's why we just left it as positive 4 root 5. So that's an example of when the sign is already printed. Versus, going back to the notes, if you introduce the radical, you don't know which sign the answer is, so you have to use both plus and minus options. Okay, if you introduce the radical, you have to use both plus and minus options. An example of that would be like when we had a quadratic. Okay, here's a quadratic. Can you think of 2 numbers that multiply to 3 and add to 5? Multiplies to 3. What multiplies to 3? 1 times 3. 1 and 3, does that ever add to 5? No. So factoring doesn't work. What's another way to solve this? Just hate the song. What's the song?
Adele, Rolling in the Deep.
Right. So what's the math version of Rolling in the Deep called? There we go. Say it loud, Eric. Quadratic formula. So you'd have to do the quadratic formula. Minus 4ac all over 2a. And see how, was a square root originally in the problem? No. But later we applied the square root. Using the quadratic formula, we introduced the square root ourselves. That's why we have a plus and minus. Okay, so that's a situation where we're applying it ourselves. So keep that in mind as we go through our notes today. Okay, for our first examples, we're going to find all real roots starting with taking a square root. Find all the real roots. Are real roots allowed to be imaginaries?
No.
No, that defeats the purpose. If it's real, then it's not imaginary. Okay, so example 1. Find all real roots of 81 using the square root. Alright, so using the square root, we would take the square root of 81, and what do we get? Okay, I've heard 2 answers. I've heard 9, and I've heard plus and minus 9. We applied the square root ourselves, so it needs to be plus and minus.
Good job, Harry. So proud.
Okay, so again, at the beginning, the square root wasn't in the problem. We applied it ourselves, following the directions, so therefore we'll do plus and minus. Oh, that's part of it. Oops. This isn't moving like I want it to. Okay, let's try this one. Example 2. 0.0049. Same directions. Finding all the real roots. It looks like the number 49, and we know the square root of 49, 7, or plus or minus. Okay, so let's see how it is affected with a decimal. Okay, pull out your calculators, please. Even your phone calculator can do this. So find a calculator, pull out an app or the real calculator. We need to put in 0.0049. Clear out the old stuff. Okay, 0.0049 and take the square root. Do you have one of mine? Square root is right here, above the x squared button. Oops, wow. That's not what I wanted. 0.0049. Okay, who has the answer? Nathan? Great. 0.07.
No, it's plus minus 0.07.
Ah, yes. And we applied the square root ourselves, so it will become plus and minus. So a lot of what we're doing today is information you've already learned. It's just on a slightly more difficult level. Okay, same directions, except for we're going to change it up to a cube root. Raise your hand if you can tell me what a cube root looks like.
It's a 3 instead of a 2.
Yes, it's a 3 instead of a 2. This square root actually has a hidden 2. If it's not written, it's assumed to be a square root. But remember, the index right here tells us the power. We could write a 2 there. So in this case, we'd write a 3. All right, so ours is going to be negative 125. Find all real roots using the cube root. What does cube root mean? Okay, so we apply the cube root of negative 125. We have to find not a pair of 2, but a pair of, or group, I should say, of 3. Does that make sense? The index is 3, so we want a group of 3. Some of you might already know this answer. If we don't know it, we can just do a factor tree like we did in the startup. Okay? Haley, can you tell me 2 numbers that multiply to negative 125? Manuel, are you on the calculator? Okay, thank you. 2 numbers, Haley, that multiply to negative 125? What do you notice it ends in, Haley? 5. So we can divide by 5, and that should help you. Yeah, negative 25 and 5, right? We can break down negative 25 into what? What 2 numbers multiply to negative 25? Styles, that's a phone that needs to go away. What times what is negative 25? Negative 5 and 5. Okay, so rule with the square root is up above was it had to be the same number. We knew the square root of 81 was 9 times 9, because 9 and 9 are the exact same number. Okay, here we're looking for 3 of the same number. Are all these the same number? No. No, we have a mixture of positives and negatives. So what number times itself 3 times is negative 125? Negative 5 times negative 5 times negative 5. A negative times a negative is a positive times another negative is a negative. So if we make all these negatives, that would be a working option. So we have 3 negative 5s, and based off the index, we're going to find a group of 3, which pulls everything out. Okay, so the cube root of negative 125 is negative 5. Now here is a rare situation where we wouldn't put plus and minus because it actually came out as a negative. Does that make sense? Came out as a negative even though we applied the root. This is a rare situation. But generally the rule applies. Just like I before E except after C and on the word weird.
If it's a cube and it's not a negative number, couldn't it not be negative? Like that,
You'd put
positive.
well, if we did positive 125, that would have to be positive 5.
Yeah, so it could be
The plus and minus really goes with the even powers more. Yep. The even indexes. Alright, so here's a decimal one. 0.008, example 4, same directions. Find all real roots. These are real numbers because real numbers are counting numbers, positive and negative, decimals and fractions. Finding the real roots. Yeah. Okay, 0.008. Okay, if you have one of my calculators or if you have a scientific calculator, pull it out. Let's look at what the fraction is for that. Okay, if you have a graphing calculator, put 0.008, and we actually have a feature that will change it to a fraction. Does anyone already know how to change it to fraction? Yeah. How do we do it? Oh, you have a fraction decimal button. Okay, if you have one of these TI calculators, hit math, which is right below the green alpha button. Hit math, and then if you look here, number 1, we'll change it to a fraction. So you just hit enter and enter again. The fraction is 1 over 125. Another way you could have done it is the 8 is in which place value? The third place value, but it actually has a name. We go tenth and 100th, 1,000. And if you simplify this, you would eventually get back down to 1 over 125. So you can do it the same way, just by hand. It'll take a little longer. Okay, so it asks us to find all real roots using the cube root. So we can actually apply the cube root or any of the radicals individually to the numerator and individually to the denominator. For the numerator, we're looking for a number times itself 3 times that is 1. Lisa, what do you think that is? What number times itself 3 times is 1? 1. 1 times 1 times 1 is still 1, correct? Yeah. And what number times itself 3 times is 125? 5. 5 times 5 times 5, right? Okay, so here's a quick question. Can this one be plus and minus? Would a negative times a positive times a negative, or that doesn't work, did it? A negative times a negative times a negative ever give us a positive? No. No. Okay, so we're going to leave it as 1/5. So the rules up above actually you only apply to the even powers. So like the square root, the 4th root, the 6th root. Because when you multiply a negative 3 times, it's still going to be a negative. Okay. Any questions before we move on? Alright, then we're going to go to simplifying, which you guys already know how to do. We're just going to add in different powers of the radical. Simplifying radicals, example 5. Square root of 81 x to the 4th. Square root of 81 x to the 4th. Would you show me with your fingers, please, what's the index for the radical? Show me with your fingers in the air. What's the index for the radical when it says square root? Show me with your fingers in the air. What's the index for the radical when it says square root? Good. It is a 2. That's the only one we don't write. You can write it if you want. It's just a little bit redundant. Okay, but this is a 2, which means we're looking for a pair. Right, so we have to break it down so we can find those pairs. So for 81, how does 81 break down? I ran out yesterday. I have a napkin. No, actually I have tissues in my purse. I'll give you a real lotiony soft tissue. Better than school tissues anyway. You got a better deal out of that.
Just get the special bracket.
Okay, guys, root 81. How does that break down? 9 times 9. And you can keep going to the 3's, except for I notice right here, aren't we looking for pairs? And this is already a pair, so I'm going to stop. So if we write it down, we have 9 times 9, and how many x's are there? 4. There are 4 x's. Just like the number 2 when we expanded, we found 4 x's. Right? So if we see a pair, circle them. Are there any pairs of x's?
Yeah.
How many pairs of x's? 2. Excellent. So everything pulls out. Okay? Benito, can you tell me the answer when we pull everything out? Great. Now, was the square root already there?
Yes.
Yes, square root was already there. So it's already taken the form of positive. There is at least one on your homework where it has a negative sign right here, and so it will take the form of a negative. So just be aware of what sign is in front of the radical. Okay? I'm going to give you guys one to try with your partners. Example 6. Let's see. Okay, take a look at the index. Show me, before you write down, show me what's the index. Thanks for showing me up in the air. What's the index? So you should find a group of this many, right? Group of 4. Okay? Go ahead and simplify that. Simplify it. Simplify means make it more simple. Okay, right now we have large numbers. Let's break it down. Find some things to pull out. So we need to go 4 right there. Okay, how many x's right there? Or, I said it backwards. How many x's? 10. So we write out 10 x's. And then how many y's? All the way across. So then we look for groups of 4. Pull out. Okay, now you put the 4th group. 4 and the square second. Yeah. All the way across. Okay, and then find groups of 4. What? I wish you asked some questions. These are expanded. So how many x's? Write out how many y's there. Because of the index. It's a 4th group. So 4th is above that little list area.
I don't know.
4th is. Manuel?
Would you say move the whole
You didn't say letters. That's what I just find 4 y's. So there will be a couple things that stand underneath. So you should have expanded it out. How many x's were there?
10.
How many y's were there?
5.
Good. Okay, Emily. Now we find groups of how many? 4. Excellent. So here's a group. Pulls out. Here's a group. Pulls out. What happens with these two x's? They stay, because you don't do x's and y's. Good question. Has to be the exact same number or variable. Here's a group of 4 y's, pulls out. So 2 x's pulled out and 1 y pulled out. How could we write 2 x's? Yep, so you could write that x squared y in the beginning. 4 through, it's very important you put that 4. If you don't put the 4, it's a square root, and that's different. Now what's remaining underneath? There's 2 x's, so that'd be x squared y. It's all multiplication. Okay? And the root was already there, so we're done. Okay. Right. It's time for rabbit cage.
Oh, great. We're going to put a rabbit in the cage.
Okay, any final questions on either of these before we move on? Amy, you good?
Yeah.
What did
you just say? Said we'll go sweating.
Kills rabbit.
All right, last section and we're done. We're going to multiply radicals. Okay, we have cube root of 4 times the cube root of 16. Write it down, please. Cube root of 4 times the cube root of 16. All right, rabbit cages. Who's ever had rabbits? Anyone?
Bunny.
Oh, there are.
When I was young, I had a bunny named Wang, and he went away.
Oh, sad. I've never had a rabbit, but my best friend in high school was a rabbit lover, and she had rabbits.
I'm straight up serious. I had a bunny named Wang when I was like 3.
They should run away and your parents gave it away.
Oh, no,
Because for years and years, when we first moved to Utah, we lived in an apartment in Murray, and there's this one day when it was just my mom and I, when we woke up and the front door was wide open. And so my mom created the story of how we were robbed while we were sleeping, and that the robber came into my bedroom as a little 6-year-old and stole, only took one thing, went into my closet and took my little children's-sized sewing machine. That's the only thing they stole, and they left. But really, as I found out like 2 years ago, so now that's a long, like 20 years later, that really she was afraid I was going to sew my finger, and so she sold it. So she was the robber, went into my room, took my sewing machine and sold it to some other poor child. And you know what? I blame that now because now I can't sew. I can sew straight lines, but I can't read a pattern. I can't do anything. Mom just says, "Here, sew this." I go, "Okay." I sew a straight line, but I don't understand how to read a pattern, and I'm really terrible at sewing. It's all because she sold my sewing machine when I was 6. It was just about no, maybe your parents gave away the rabbit.
We sold them because it got too hot or something. And it got like
Okay, back to the rabbit cage example. There's a real reason we're talking about rabbits. All right, so you don't just let rabbits really roam free, right?
Oh, we let them.
Wait, I know what we're getting a class pet and it's going to be a rabbit.
That'd be kind of fun to have a class pet.
Yeah, it was.
Like in elementary, we had Stimpy. That was our 6th grade rat.
Now listen up, ladies.
All right. Okay. Just taking forever. Okay, a rabbit cage is where the rabbits stay, right? So that they don't run away, don't get lost, or pretend to be lost. Okay? And the basic idea is you only put rabbits of the same species together in a cage. So that you can only have rabbits multiply when they're of the same species, right? Think about that. Okay, so for our rabbit cage rule, our rabbit cage is acting as the radical sign. And there could be an index up here, or it could be a square. Okay, we're only allowed to multiply if they have the same species of rabbit. So they have to be of the same rabbit cage. So we can only multiply, which this also applies to adding. We can only, let's see, what's a good word? Combine rabbit cages if they have the same radical. Okay, so think of the radical as being the rabbit cage, which is trapping a bunch of rabbits, keeping them in check. Oops. Okay, so look at these two radicals in number 7. Are they the same rabbit cages? Okay, remember the root sign is going to be the rabbit cage. Are they the same? Yeah, they're both have an index of 3. So we are allowed to let the bunnies multiply. Okay? So, which means we can stick all of them into the same cage because they are of the same species. 4 times 16. Now we're not going to multiply those together with our calculator and get a large number because we're always looking to simplify these. So we don't want to go up to a large number. We want to break it down. Okay? 16 breaks down into what times what? 4 times 4. Now you can go all the way to the 2's, but if you notice right here, how many 4's do we currently have? 3. We have 3 4's. And our index is what number? 3. So therefore we're looking for a triple. You could go to 2's if you want, but you'll have 2 separate triples. Here we already have a group of 3. So that pulls out, and we're left with 4. Now look in front of the radical. Was it originally positive or negative? Originally positive.
We're not done yet.
Okay? Oh, we have 2 more. Just practicing multiplying, and then we're done. Okay, example 8.
That's a lot of
Yeah, it's because we're doing 2 sections today.
Oh.
Because we won't be done by the time the term ends. Can you believe that Christmas break is in?
Yeah, after we get back.
There's 3 days this week left.
Oh
After
my
today,
goodness,
4 days next week. It's Christmas break, and then we only have 9 days when we come back.
I
Yeah,
can't wait.
I'll be going.
Basically, the term ends in approximately 8 school days. All right, number 8. Do they have the same rabbit cages?
No.
No.
No, so therefore they're not allowed to cross multiply.
Oh.
Because this is a square root, which has a little 2 here. This is a cube root, which has a 3. They're not allowed to cross multiply.
That's math.
But what we can do is try to break them down individually. Does 3 break down?
No.
No. But does 8 break down?
Yeah.
Yeah, we went over this trick earlier. What number times itself 3 times is 8? 2, 2, and 2. So we have, not cube root, it was a square root. Square root of 3 times the cube root of 2 times 2 times 2. Now what's the index on the second radical? The index isn't 2. The index here is 3. So we're looking for a group of 3, which we have. So it means all those 2's pull out. Now, some of you are going to write it like this, and that's a little weird.
Yeah.
Okay? Just like writing x2, that's weird. We usually write the coefficient in front and then the variable. Right? We write 2x. So when I write our final answer, it's going to be 2 root 3. And if you look, at the beginning, it was a positive times a positive. So it answers a positive.
Wow.
Okay? Even though they weren't of the same rabbit cage, we can't just do, oops, where's my marker? You can't just combine 3 times 8. You can't let those multiply because they're different rabbit cages, but we can still simplify. All right, last example. Example 9. Okay. 6. 4th root of 256 times 4 times the 4th root of 243. Not only can the rabbits inside of the rabbit cage multiply together, because do we have matching rabbit cages? Yeah, they're both 4th roots. You're also allowed to multiply coefficients. Okay? You cannot multiply coefficients or the numbers underneath the radical unless their rabbit cages are the same. So we are allowed in this case to do 6 times 4. And then the fourth root of, we're allowed to allow the rabbits underneath to multiply. Welcome. Everyone know? Marina? Alright, so we're not going to multiply 256 times 243 because that will be some large number. Remember, we're trying to break this down. So, separately, we're going to do trees for 256 and 243. To make this go faster, let's have this side of the room do the factor tree for 256. This side of the room, do the factor tree for 243, please. Okay? Work together, get the factor tree for your assigned area. So, Amy, you're breaking down 243, and it's not prime. 243 is not prime, so it does actually break down.
Well, let's just. It's all the same. Well, yeah, but she's. Okay. Because then it's just going to be.
43. So the calculator out and find out what divides into 243.
That was a rhyme right there.
That was unnecessary.
There you do it. The calculator, break down 243 is.
Yeah.
It does divide.
Good job, team.
Break down 243. You have a big calculator. You should go do that. 243. On this side, what have we found 243 is divisible by? 243 is divisible by 3. So do 243 divided by 3 to break it down. Where's your side? On the back side?
It's 3 times 3 times 3 times 3.
Okay, make sure you're doing full notes. So we turn in our portfolios in every turn. Okay, for a grade. Alright, this side. Help me out, please. 256 breaks down into.
Wait, like, what do you mean? Oh, okay.
What
like
times 1 is 256?
64 and 4.
Okay, and then.
So 64 would be 16 and 4.
And then 60 would be 4.
And then 8. 8 and 2.
Okay, or 4 times 4.
Or that, whatever.
And you can break down in twos,
It's
but I
all
have.
the same.
2 groups of 4.
But do we want 2 groups?
No,
We want one big group of 4,
4.
which is exactly what we have right here. Okay, 243. 3 times what is 243? 3 times what? 81. 81 breaks down into 3. Yeah, we can do 9, 9 and 9, and then 3, 3, 3, 3. Look, group of 4, but this one guy's hanging out. So underneath the radical, what will be left? 3. Okay, so if it helps, I can rewrite all the ones that we've circled in case people get confused where we're getting these from. Okay, there are 4 4s, which is a group. Pulls out. There are 4 3s, which is a group. Pulls out. So a 4 pulls out, a 3 pulls out, but originally there was 6 times 4. What is 6 times 4? 24. So I'll have to multiply all those together. Underneath the radical will be 3. So if we multiply all those together, then we're done. What's 4 times 3 times 24? 288, 4th root of 3. Okay, so at the beginning it was a positive times a positive, which is a positive. Right. Good. We have tons of time. We can work on our assignment. This is great. And I'll help you get started to make sure you know what you're doing. The assignment for today. It comes from 2 different pages, but it's only like 14 problems. 426 2 through 16 even, and page 433, 1 through 6 all. Right? Okay, before we move on to work, I'll help you get started on these. I'd like you to pull out your cell phones, please. I know you have them. Many people have them.
Struggle's real.
Yeah, but eventually I'm sure they'll be
Get
able
off
to.
the Christmas book.
Cool. All right.
What's this?
Oh, is this a reminder on the way?
Remind 101.
Oh, good.
Many of you need a reminder what your homework is.
Yes.
So,
Yes.
please join my secondary math 3 group. Pull out your phones. I'll remind you of tests coming up too. All right? So, type in this number, 801-590-7147. And in the message area, put @B221E. And then you'll be joining the secondary math 3 group.
That's cool.
I think it's, yeah, text you and says, welcome, you've joined this great class. I texted it yesterday, and that's what I got. Okay?
Yep.
No, that's my whole name.
Oh my god, it is style.
Thanks, style change.
I don't know.
Have you signed up before?
Yeah, if you don't want it, you can cancel it. And you can't see it, like, you know how it says, reply to stop, like, you don't see that.
Ooh, 120. About 40.
But
160. 200.
your parents can sign up too.
You're way too.
I sent out an email to all the parents, whose emails I did have, and your parents can sign up too. So,
I think my mom signed up.
pass the word on to your parents, please. All right, let's start doing our homework.
Yeah, I didn't even